Hi guys, welcome back to my channel. Today we are learning about molar volume and one equation. You know that PV is equal to nRT, and I will show you when can we use the molar volume and the PV is equal to nRT, and what's the link between PV equals to nRT and the molar volume. Most of the students, they are getting confused with molar volume and PV equals to nRT formula. Today I will teach you how to use molar volume formula and PV is equal to nRT formula. Let's start the molar volume first. So we know that 1 mole of any gas, 1 mole of any gas at STP, I will tell you what's the meaning of STP, occupies 24 dm cube of volume. STP, standard temperature pressure. Sometimes it is called room temperature pressure, but don't think the room temperature be 10 degree or 15 degree. So the standard room temperature would be 25 degree. Okay, let's see. So 1 mole of any gas at standard temperature pressure occupies 24 dm cube of volume. Mole equals to V over 24 dm cube. The volume should be in the dm cube, and this formula is only applicable for gaseous substances, not for solid, not for liquid. We will do one question and we will apply this formula for that question. 1 gram of calcium carbonate, CaCO3, is completely decomposed to form calcium oxide and carbon dioxide gas. We did this question in my previous videos. For that question, we worked out the mass of the calcium oxide form. Here we are doing what's the volume of the carbon dioxide gas form. So 1 gram of calcium carbonate is completely decomposed. Completely decomposed. When you heat it, it gets decomposed. Decomposed to form calcium oxide and the carbon dioxide gas. So question number, find, we have done question 1 in my previous video. Now find the volume of carbon dioxide gas form. Find the volume of CO2 gas liberated or formed. So we can use this formula to work out the volume of the carbon dioxide gas form. First of all, to work out this, we have to write the balance form of its chemical equation. Calcium carbonate, when you heat it, you will get calcium oxide plus carbon dioxide gas form. Mass of the calcium carbonate is given. So what's our approach? You have to figure out the mole of calcium carbonate first, because the mass of calcium carbonate is given and there is no link with the mass and the volume. So the first thing is to work out mole of calcium carbonate form. Guys, please copy down that one because I want to rub this one. Is that okay, yeah? See that 1 gram of calcium carbonate, which is given in the question, and we have to work out the volume of the carbon dioxide gas form. Okay, use the formula to work out the mole of calcium carbonate. Mole equals to mass over its MR. Mass is given as 1, and I don't want to waste your time. We know the MR of calcium carbonate is 100. So, not 1 mole. Look at the theoretical ratio of all the reactant and the product. 1 mole react to form 1 mole of calcium oxide and 1 mole of carbon dioxide gas. So we got 0.01 mole, same as 0.01 mole and 0.01 mole of carbon dioxide gas form. Now use this formula to work out the molar volume. So rearrange that formula. V equals to mole time 24, and that 24 should be in decimeter cube. So mole equals to 0.01 times 24, which is equals to 0.24 dm cube. Suppose I want to convert that dm cube to centimeter cube. What should I have to do? What's the conversion factor? You have to time by 1000. So I want to change that one. I want to get the answer in centimeter cube rather than in dm cube. So whatever the answer you got, change into just times by 1000. That's the conversion factor. 0.24 times by 1000, which is nothing but 224. So 24, just a moment, hang on. I will simplify that one. So 0.24, you can write 0.24 divided by 100 times 1000, easy. So this 20 cancel, that 20 cancel, so 240 centimeter cube. That's the volume of the carbon dioxide form when we burn 1 mole of calcium carbonate gas. Let's do one more question, and then we can jump to the PV equals to nRT formula, which is an ideal gas equation. One more question, guys. My strong tip for you is that don't try to memorize the formula or don't try to memorize the chemistry. Try to learn the chemistry. Chemistry learning is like a fun. Let's see. One more question. Similar to that one, based on the molar volume formula. So, find the volume of ammonia form when 2.8 gram of nitrogen reacts with excess hydrogen. Whenever you will get this kind of question, guys, try to balance the equation. Sometimes that balanced form of chemical equation is given in the question paper. So let's see. N2 plus 3H2 react to form 2 mole of ammonia. All are gases. Nitrogen is gas, hydrogen is gas, and ammonia is also gas. And the molar volume formula is only applicable for the gaseous substance. Let's do that one. So 2.8 gram is provided to you. First step is work out the mole first. Mole equals to mass over its MR. mass is 2.8 gram, amount of nitrogen. We can check the AR of nitrogen from the periodic table. 2 nitrogen, so 14 times 2 is 28, which is nothing but 0.1. I always give you a divisible number. I don't want the student get confused with the fractions. So I normally give you easy numeric value so that you can easily divide it. 0.1 mole. Now, look at the molar ratio. Molar ratio between nitrogen and ammonia is 1:2. That's the theoretical molar ratio, which is 1 mole of nitrogen react to form 2 mole of ammonia. And whatever the mole you got just now, 0.1. So you have to times by 2 to get the mole of ammonia. 0.1 times 2, 0.2 moles of ammonia. Do you want to apply the molar volume formula? What's the molar volume formula, guys? Just now we have done it. Moles equals to mole equals to V over 24. Okay. So rearrange it. V equals to mole time 24. How many moles we got? 0.2. 0.2 times 24, which is equals to how much, guys? 4.8 dm cube. Okay, I just gave you the question based on the amount of mole and the volume. Sometime they will give you a volume and you have to work out the number of moles formed from the question. So it's easy to rearrange. They will ask anything. Rearrange this formula. Now, when can we use this formula? And we have one more formula which is similar to that, which is called an ideal gas equation, PV equals to nRT. We will see the difference between molar volume and PV equals to nRT formula. PV equals to nRT, which is the ideal gas equation. Where P represents pressure, V is nothing but volume, N is the number of mole, P equals to pressure, V equals to volume, N equals to mole, R is the ideal gas constant, and T equals to temperature, T equals to temp in Kelvin. And just now we have discussed this formula, mole equals to, mole equals volume over 24. This formula we can use only when STP is given. Standard temperature and pressure is given. This formula is only applicable in the question when it is provided as STP, standard temperature pressure. This formula you can use to any question with any temperature, any pressure, any volume. This is only for STP. It means room temperature, 1 atmospheric pressure. But here you can use PV equals to nRT for any temperature, for any volume, for any pressure. Both these formula is used for gaseous substance, not for solid, not for liquid. Let's do some question based on PV equals to nRT formula. Pressure, what's the unit for the pressure? Pressure unit is 100 kilo pascal or 100,000 pascal. What's the unit for the volume? Unit for the volume here is meter cube. I will show you the conversion meter cube to decimeter cube to centimeter cube. No worries. R, what's the value of R? R value is constant, which is given sometime in the question, 8.31 joules per Kelvin. And T is temperature in Kelvin. How can we change Celsius to Kelvin? So K equals to 273 plus degrees Celsius. That's the conversion factor. Volume equals to meter cube. These are the standard unit. Whenever a question is given to you, you have to focus that all these parameters should be in this unit, because these are the standard unit, guys. So volume meter cube, we can change it into dm cube. Dm cube can be changed into centimeter cube. Okay, just please copy down that one. I will show you how to change meter cube to dm cube and dm cube to centimeter cube. Okay, let's see. How can we change meter cube to centimeter cube to, first of all, meter cube to dm cube, and dm cube to centimeter cube. Let's see. Look at the meter cube to dm cube. So 1 meter cube equals to 1000 dm cube. 1 dm cube equals to, again, 1000 centimeter cube. I will go back in the reverse way. This is the easy way. We can do the conversion, but we want to, when we have to go back, some students get confused with that. Let's see how can we go back. When centimeter is given to you, how can we change into decimeter cube? Okay. Look at that. So centimeter cube to dm cube. 1 centimeter cube to dm cube, 1 over 1000, which is nothing but 1 into 10 to the power of minus 3 dm cube. So 1 dm cube to meter cube. 1 dm cube equals to 1 over 1000 meter cube, or 1 into 10 to the power of minus 3 meter cube. I want to change 1 cm to meter cube. Let's, how can we do the centimeter cube to meter cube? 1 centimeter cube to dm to meter cube to m3. 1 centimeter cube equals to 1 over 10 to the power of 6 meter cube, which is nothing but 1 into 10 to the power of minus 6 meter cube. Please copy down this type of conversion, which is very important, guys. And we will do some questions based on the PV equals to nRT formula. I've seen that question in many past papers, whether it's OCR, AQA or Excel. We will do those questions in my next videos. Till that, I want to wind up my lesson here. So guys, I will see you soon. Thank you so much for watching my videos.